Hello everyone, welcome back to the class of Harish Sir Physics. Now I am going to continue gravitation part 2 in this video. If you have any doubts, can please refer my previous video. In this video, I am going to start with the gravitation potential and the potential energy. So you can take 2 point masses. One is mass m1. One is mass m1. So this mass m1 is a m. And I'm going to consider one unit mass here, unit mass 1 kg. So it is the amount of the work done bringing a unit mass from infinity. So from infinity to a point we are bringing. So it is kept at a distance of r. It is kept at a distance of r. You can write V is equal to minus G into M divided by R. Generally, it is always can be taken as a negative. Always can be taken as negative. And the maximum value is 0. At infinity. Maximum value 0 is at infinity. Gravitational potential energy gravitational potential energy of the system of two particles so you can take these are the two masses. You can take m1 and m2. These two are kept at a separation of r. You can write u is equal to minus g into m1 m2 divided by r. So gravitational potential energy u is equal to, we can write as minus g into m1 m2 divided by r. Now the gravitational potential energy of a body at a point in the gravitational field of earth. At a point in the gravitational field of earth. In the gravitational field of earth. So in the gravitational field of earth, suppose I am taking a body. So this is the radius r you can consider. So this is the point P. We are bringing from the infinity. So from the infinity we are bringing. So at the infinity, remember potential energy U will be 0. Next we are bringing to the point P. If you write at the point P, U is equal to, you can write at the point P, U is equal to minus GMM by R. GMM by R, smaller I'm going to consider with the height. So minus G into M divided by R plus H, you can write. So this point is at a distance of R, smaller. So this point kept at a distance of R. Normally is kept at a distance of R. At this point, so this is the mass M. At the center, you can write U is equal to potential energy at the center. At the center, U is equal to 3 by 2 into G into M divided by R, you can write. Potential energy on the surface of the earth. Suppose if you take at the surface, so this is at the surface, at surface you can write U is equal to minus G into M divided by R, that is equal to, you can write minus M into G into small r, you can write, because Gm by R square you can write as a G, you can write. So I'm writing U is equal to minus M into G into R. At the surface is the minus mgr, at the center. So this is at center. At center, U is equal to minus 3 by 2 into gmm divided by r. Very, very most important point. And at the surface, U is equal to minus gmm by r. Now, work done. One more important point. Most of the object exam, they ask basing on this concept. Work done in bringing otherwise lifting. You can write lifting instead of bringing. Work done in lifting. So not the bringing, it's lifting. Work done in lifting a body from center of surface of earth to a height r. To a height h or r against gravitational force. If we take work done is equal to, generally you can write minus g into m divided by, this is the final potential energy, so minus g into m divided by r plus h plus initial, so g into m divided by r. So this is the final, this is the initial. So finally we'll get gmm into, if we take, we'll get gmm into h divided by, you will get r plus h into r, you will get. So this is energy in the form of potential energy. So you can write delta U is equal, change in potential energy. You can write m into g into h divided by 1 plus h divided by r. You can write delta U is equal to m into g into h divided by 1 plus h by r. This is the change in potential energy. Suppose if h is less than r. If h is less than r, you can write work done, otherwise change in energy. So you can write as m into g into h. One of the important formula. Next one, escape velocity. What is escape velocity? The minimum velocity with which a body, if you project, it will escape the out of the earth gravitational influence. That is said to be the escape velocity. So you can take, this is the radius r. So if we project, so anywhere, so with some velocity ve, so it should lose the earth gravitational influence. That is said to be the escape velocity. So here total energy will be 0. Potential energy plus kinetic energy can be taken as 0. If you write potential energy is equal to minus kinetic energy, we can write potential energy, what we can write, minus g into m divided by r. Kinetic energy half into m into v square, you can write m gets cancelled. We know g is equal to, so you are going to project against, so you can take outside minus, so minus or minus plus here. So we can write gm divided by capital R is equal to v square divided by 2. So this is the escape velocity. We know g is equal to gm divided by r square, we know. So gm value, what you can write, gr square we can write. So gm is equal to, can write as a gr square. So in the place of gm, I'm going to write gr square. So gr square divided by r is equal to v square by 2. R gets cancelled. V is equal to, we'll get square root of 2 into g into r, you can write. V equal to square root of 2 into g into r, we can write. Otherwise, if we write in terms of capital G, we can write V is equal to square root of 2 into g into m divided by r. Both are correct. And here, one more important point, they asked, even in the objective exams, many objective exams, they asked. So make sure here, escape velocity is independent of angular projection. Suppose if you project with any velocity, after that if they change angle also, the velocity will be remain same. What about the escape velocity? Escape velocity if we substitute, so g value and r value, so v is equal to square root of 2 into g value 9.8 into radius of the 6,400 kilometer into 10 power of 3 kilometer. So radius of the 6,400 kilometer. We will get v is equal to, you will get 11.2 kilometer per second. So remember, if you project any body with a velocity of 11.2 kilometer per second, surely the body will lose the earth gravitational influence. That velocity is said to be the escape velocity. So I am giving this is VA, escape velocity. And it depends on the mass of the planet. Remember, it depends on mass of a planet. Depends on, one is mass of a planet, depends on mass of a planet, and radius and height. Radius, comma, height of a projection. Height of projection. So once again recalling, it is independent of angle of projection, but it will be depends on mass, radius, and the height of projection. Next one, orbital speed. Orbital speed. Orbital speed. If we take orbital speed, the horizontal velocity is required for an object to revolve around the planet. To revolve around the planet. So you can take an object is going to revolve in the planet. So this is the mass m. You can take radius r. Radius r. If you project, it should be revolve. It should be revolve in this path. So what about the velocity here? Velocity v naught. So this is, we know, centripetal force mv naught square by r plus h, and gravitational force between the two bodies g into m divided by r plus h. You can write r plus h whole square, you can write. So we'll get mv naught square by, so this should be by mv naught square by r plus h is equal to, mv naught square by r plus h is equal to, you are going to get g into m divided by r plus h whole square. So this square and this gets cancelled. So this m and this m gets cancelled. So v naught square is equal to what you can write, gm divided by r plus h you can write. You can consider r plus h as a small r. So v naught square equal to gm divided by r, otherwise r plus h gm by r. So v naught is equal to square root of gm by r you can write. Otherwise, instead of that, you can write gm equal to gr square. You can write square root of gr also we can write. So what about the relation between escape velocity and orbital velocity? Relation between escape and orbital speed. Already we know escape velocity is equal to escape velocity v is equal to, you can write square root of 2 into square root of gr, you can write. Orbital velocity v naught is equal to square root of gr, you can write. So you can write v is equal to square root of 2 times of the v naught. Escape velocity equal to v is equal to square root of 2 times of the v naught. So orbital velocity, if you substitute g value and r value, you will get 7.92 kilometer per second in the orbital speed. 7.92 kilometer per second. So v is equal to square root of 2 times of the v naught. Next important point here, energy of an orbiting satellite, very most important one. Energy of energy of an orbiting satellite. Energy of an orbiting satellite. Already we know potential energy. Potential energy is equal to what we know, minus G into M divided by R we know. Then kinetic energy. So this is potential energy. If we take the kinetic energy K equal to what we know, half into M into V square. So this will be the orbital velocity. We know V is equal to square root of Gm divided by R we know. So if we substitute here in the kinetic energy, K is equal to, we'll get half into M into square root of V square. V value square root of Gm by R we know. So we can write Gm by R. So what we are going to get? G into capital M into small m divided by 2 times of the R kinetic energy we are getting. Kinetic energy. And whereas total energy, so if I take the total energy, both the summation of kinetic energy and potential energy, so you are going to get minus gmm by r plus gmm divided by 2r. So if we calculate, so the LCM is the 2r, you are going to get minus g into m divided by 2r. So if you observe the ratio of the kinetic energy, potential energy, and total energy, if we take note point, you can keep, it is important objective. So total energy is equal to minus kinetic energy, that is equal to potential energy divided by 2. Very, very most important relation. If we take the ratios, potential energy is to total energy is to kinetic energy. So what we can say, potential energy is to, so minus 2 is to 1 is to minus 1 you can write. Important relation, make it box this one. If we take the graph, if we take the energy graphs, you will get, so this is the kinetic energy because in the positive, but total energy and potential energy are negative. So you can write total energy and potential energy you can write here. Look at here. Here, what about the work done when it is revolving? So very, very most of our students generally will get confused here. Which formula we should apply? Work done of a satellite if radius, if changing from, if changing from radius to R1 to R2. Look at here. If they mention satellite condition, so we should consider the total energy. So work done is equal to total energy final minus total energy initial. If it is not the satellite condition, generally we should go to the potential energy. If it is the satellite condition, we should go to the total energy. So double equal to minus G into M divided by 2 R2 minus or minus plus G into M divided by 2 R1. So what we'll get? So double equal to G into M divided by 2, take common, we will get 1 by R1 minus 1 by R2. This is the work done in a which condition? Satellite condition. So this is, make it star here, satellite condition. You can write W equal to gmm by 2 into 1 by r1 minus r2. If it is not a satellite or orbit, satellite or orbit, you can not only satellite, orbits if they mention. If not a satellite condition, if not a satellite or orbit, they given the triangle of the sides are increasing, if they given like this, so work done is equal to, you can write G into M 1 by r1 minus 1 by r2. This is the work done. This is not a satellite condition. If it is not a satellite, you can take as a potential energy, you can consider. If it is a satellite condition, we will consider total energy. Make it star. You can take screenshot of this. Very, very most important condition. And one more important concept. Most of the objective question there is a possibility to get from this. How behavior of a body project vertically up projected vertically up with different velocities. Simple condition, I'll say. If it is body is projected with the velocity v less than ve, what will happen? V greater than ve, what will happen? V is equal to ve, what will happen? So already we know, if we project a body with a velocity greater than escape velocity, it will lose the earth gravitational influence. So here I'm taking the total energy initial first case. So this is the first case. I'm taking v less than va. Total energy initial is equal to total energy final. You can write total energy initial. What is the total energy initial? Potential energy initial plus kinetic energy initial. Just go through the concept, don't buy it, dear students. Potential energy final plus kinetic energy final. If you take the potential energy initial, what you can write? Minus g into m divided by r, you can write, plus kinetic energy initial half into m into v square, we can write. That is equal to potential energy final minus g into m divided by, with the height r plus h, plus kinetic energy final half into m into v infinite square. I'm going to write. So this is the kinetic energy final. So if you body is projected less than v, so it will go some more height and it will come back. So it will reach maximum height. Body will reach maximum height. Body reaches maximum height, but it will fall down. Body reaches maximum height, but it will fall down. So at that time, you can consider v infinity is equal to 0. So that means final kinetic energy won't be. So you can write just simple condition minus g into m divided by r plus half mv square is equal to minus g into m divided by r plus h. So this velocity, because the body is go up, so it reaches a maximum height. So it will fall down. So it will be 0. So minus gmm by r plus half mv square is equal to minus gmm by r plus h. So if you write, so if you find out, we'll get, suppose if I consider velocity ve is v equal to v divided by n times, if I consider, so it will reach the height of h is equal to r divided by n square minus 1. Otherwise, you don't need to remember the formula. Just go through this basic one and you can substitute the given values, you'll get the answer. So when you projected with a velocity of v less than va, suppose if you project with a velocity of v greater than va and v is equal to va. So if projected with v greater than v, what will happen? If you project with the v greater than va, so the body will reaches into the interstellar space. So total energy at surface of Earth is equal to total energy interstellar space. Total energy in interstellar space. So total energy at the surface of the Earth, you can write minus g into m divided by r potential energy plus half mv square is equal to the energy. The body reaches into the interstellar space, so that means the body will reach the maximum, so infinite height. So gmm by r plus height will be infinity plus half into m into v square will be, so this will be the v infinite score. So here height will be infinity, so potential energy in the interstellar space is 0. So potential energy final will be 0. So previous condition, kinetic energy is 0. In this condition, potential energy is 0. So final potential energy, final kinetic energy is 0 in the two different cases. So minus gmm by r plus half mv square is equal to half into m into v infinite square. So by using this condition, you can solve the problem. You no need to by at any point. So just go through it. So if you want, if you continue this relation, you will get V infinite is equal to, so you know, V is equal to what we know, V is equal to square root of 2 gm by r you can take. So if we substitute, you'll get it. So V infinite square, V infinite is equal to, you can write square root of V square minus VE square, we'll get it. So you no need to go through this formula also, but by taking this formula alone, you can do it. If the given value substitute, you'll get it. Suppose if it is projected with the last one, if you projected with the velocity V is equal to VE, what will happen? If it is the V is equal to VE, we got H is equal to, previously H is equal to R divided by N square minus 1 we got. N square minus 1 we got. So that means here V is equal to VE we can write. So N value, H is equal to R divided by N values, you can take 1 square minus 1. So it will be, how much? Height will be infinity. So height will be infinity. Then you can say total energy of the body 0 at the infinity. Total energy of a body is 0 at infinity. Once again, I'm telling you. So if it is projected with the V greater than VE, V less than VE, V equal to VE, then what will happen? So V infinite is equal to, H is equal to infinity. Then you can write total energy is equal to minus G into M into M by R plus H. So that is infinity plus half into M into V infinite square. So that will be the 0. So we can consider body possess 0 value at infinity. Body possess 0 value at infinity. Zero value at infinity. Once see the quick view of this one. So if we take the three conditions, V greater than VE, V less than VE, V greater than VE. So V less than V, H equal to R dot by N square minus 1. No need to this. Just go through initial potential energy, final potential energy. If we take V less than VE, it will reach the maximum height. So kinetic energy final will be 0. If it is a V greater than V, the body reaches interstellar space. So height will be infinity. So you can take final potential energy can be taken as a 0. I hope you liked it. If you want any topic, please comment. Please like, share and subscribe my channel for more videos. Thank you.